Find the sum of the sequence. So this one I saved for last and all by itself. So we're going to talk about this type of problem here. Now again, if you look at this one here, I am going to use this last equation here. But before I do, notice this equation here on the bottom here. It starts out at k equals 1. R starts out at k equals 5. So this is our problem that we have. And I'm definitely not going to want to go through all those and cube them all, like 5 cubed, 6 cubed, all the way to 25 cubed. So we're going to use another idea here. But we will come back to this idea here to use number 4. So here it is. It's this last one here that we didn't talk about yet. So notice this. This says k equals 1 plus j to n. And that's equal to my series when it equals 1 to n minus 1 to j. So if we look at what we have here, oops, this right here, this k I have here is my j. Plus 1. So if we think about this idea, and let's say I put the other ones in, the ones I'm going to actually subtract off. Okay, so I'm going to put those in black. So it's going to be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. Okay, that's what I would be subtracting off. And then where I'm starting with this one is plus 5 cubed plus 6 cubed plus dot 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 plus 25 cubed. So I want all of this, all the green I want. The black is what I'm not using. Okay, so when I look at this here, that's my 1 to n. So that would be my 1 to 25. So this series right here of all of this, this would be my k equals 1 k cubed from 1 to 25. And then what I would do here is now I have this minus here. So I would minus the series k equals 1 to 4 of k cubed. And that's going to be this piece here. So do you see how that kind of works out for us now? Hopefully you do. So that's going to be our setup here. So that's what I'm going to use. And this would be that series 1 to 4. So there's our setup. So again, remember I'm cutting off the first 4 because I'm starting at k equals 5 here. So now we need the other formulas. So here they are. So now I'm looking at, oh, I put an n here. Look at, I messed up on my formula there. That n should have been 25. So anyway, so now I'm going to actually use my formula. So I'm going to start writing it down here because I want to be able to put everything in together. So now that first formula is going to be my n here, which is 25. Okay, and I'm going to do n times n plus 1. So that's going to be 25 times, and I'm just going to write 26 because it says n plus 1, which is 1 more, over 2 squared. And that's the first piece. And then it's minus the other one, which is going to be 4, because my n is 4 now. It's here and here. Okay. So it's going to be 4, and then n plus 1 is going to be 5 over 2. And don't forget to square them. Okay. So now I can simplify in here a little bit. That's going to be 1. That's going to be 13. I always try to do that whenever I can. So 1, and that's 2 times 5 in there now. So we get 2 25 times 13 squared, and minus, and that's going to be 10 squared, which is 100. So we get, so this results in 105,625 minus 100, which equals 105,525. So this here is our final answer. So there you go. So I can break these down even more. And this is a strange idea for us to get here. But once you get it down, it does make sense. Just lopping off those first 4 pieces, and that's why I'm subtracting it off from the whole thing.